Good morning, this is Christina Long and this is the Science 411. Today's video is over writing equilibrium expressions and we're going to be going through some guided practice today. Before we get going, there's some things to remember. You have a few tips to kind of keep in mind. Number one, you're going to only use aqueous and gas as far as states of matter. You're going to ignore your solids and your liquids. The next thing, remember that in dealing with putting stuff into your expression, their products are going to go in the numerator and the reactants are going to go in the denominator. And finally, the coefficients in the balanced equation that you're working with, those are going to go to the exponent spot. So we're going to be working through some guided practice, so here we go. So in this first equation, I've got NH3 added to H2O, and it's going to give me NH4 plus, which is an ammonium ion, and OH negative, which is your hydroxide ion. I have got 3 aqueous, and then I have a liquid. And for the sake of writing an equilibrium expression, I can ignore that portion. So I'm looking for an equilibrium constant. I'm looking for my concentration, essentially. And so I'm going to take my first product and I'm going to put it inside those brackets. And then instead of that plus, I'm going to use a multiplication sign, and then I'm going to have OH with a negative. And that's going to take care of all my products. And I only have one reactant to deal with that's left, so I have NH3. And I've dealt with everything there. I have no coefficient, so I don't have any exponents right there. So that is my expression as it needs to be. In my second example, you've got 3 different pieces to it. You have a liquid, and then you have 2 gases. And again, you're dealing with a liquid, so I'm going to ignore that. So I'm going to start off as normal. I'm going to put my Kc equals. And then I'm going to have H2, but in the equation I have 2 moles of H2, so I'm going to put a 2 up there at that exponent. Then I've got my multiplication sign, and then I have 1 mole of O2, so I'm going to put that in my brackets. And I'm dealing with all of my products in the numerator there. Now I have to go to my denominator, but I've crossed out my denominator. I'm just going to put it over 1. Do you have to put it over 1? No, but I'm going to put it there just to remind whoever is looking at this, hey, I know that there should be something for C, but it was in the wrong state of matter, so I skipped it. So I'm leaving it in that format. In this third example of writing for Kc, again, I'm going to look and examine my states of matter. I have a solid, can't use that. I have a liquid, can't use that either. I have another solid, can't use that. I have one thing that I can use. So I'm going to look and say, okay, Kc, it is a product, so I'm going to put it in the numerator, so it's going to be HCl. And I've got a 2 there, and that's because I had a coefficient. I have no reactants that I can use, so it's just HCl squared over 1. In this particular equation, I'm now dealing not with just Kc, but instead I'm dealing with Kp, and this is for my pressure constant. So I'm going to follow along similar things. So I'm going to look at my states of matter, and I have a gas and 2 solids, so I'm going to ignore those solids. And in this particular case, I have no products, and instead I've got some reactants, or at least one that I can use. So remember, pressure is going to be a little bit different. I have nothing over on my product side, so I'm going to put a 1. And then over on my reactant side, I do have 3 of my F2, so I'm going to put pressure and 3, and then that's going to be the pressure for F2. And that's the way that's going to be written out. So it's going to be pressure to the third, and the pressure is the gas, that F2. And that's how you write it out when you're dealing with pressure for a gas. In this next example, we've got a little bit more going on. I have 3 gases in one solid, so I'm going to ignore that one solid. And as a reminder, I'm looking for Kp, so I'm going to write an equilibrium expression for for the pressure. And I've got my product, so I'm going to have P2, or P squared, and that's for the gas of SO2, and that's going to be over my P squared for PBS times P cubed, and that's for my O2. So it's written a little bit different. I'm putting my substances in parentheses and using them as a subscript rather than what I'm actually putting in that bracket. And the reason I'm doing that is because, again, I'm dealing with pressure and not concentration. This last example is kind of everything pulled together for equilibrium expressions. There are 2 things that you're going to have to do in this particular case. If you notice up top, you've got concentration values for 2 substances. And again, when you're looking at concentration, you're looking at excuse me, those squared off brackets. So I'm going to go ahead, and essentially what I'm going to do is I'm going to look at my equation, I'm going to form an expression. Once I form the expression, then I'm going to take those values up top and I'm going to plug those in, and then I'm going to run the numbers for the math to get the actual value. So we might as well start from the beginning. And we're going to take, I'm going to look at my states of matter. I have aqueous, which is fine. I have solid, I don't want that, so I'm going to ignore that. I have aqueous, which is good, and then I have a solid, again, I don't want that, so I'm going to ignore it. So I'm going to go ahead and write my expression. So I've got Cu NO3 2, and I'm putting that in my bracket, and then I have Ag NO3, and because I have 2 moles of that, I'm going to put that as squared. And that is my expression. The next thing that I'm going to do now is I'm going to fill in my numbers for the expression. So, I'm getting my numbers from up top. So I'm going to go ahead and I'm going to look at that again, and I'm going to rewrite it because you guys know me, I rewrite stuff. So for my value for my copper 2 nitrate there, it's going to be 0.48 molar. And I'm not having to multiply it by anything because, well, it's just that. And then I'm going to take my concentration of my silver 1 nitrate, and so it's going to be 0.007 molar. But then I have to square that value. Once I square that value, then I've got my 0.48, and then I'm going to divide it by my denominator. And once I've done that, then my Kc value is going to be 9,790, not 59, but 95. Let me see here. 9795.92. And there is no unit there. You've got molarity essentially up here divided by molarity again. And so that's going to be your concentration. Well, actually there would be. Actually there would be there because you've got, this would be molarity squared, so your concentration is there. You don't necessarily have to use that capital M there because the constant that it's giving you is, you're talking about concentration, so you don't really have to use it. But that's the worst of writing equilibrium expressions. So I hope you guys are doing well. Know that I miss seeing you guys every day. And make sure to make good choices and clean your room. Until next time, bye.